Addition or subtraction of terms that contain radicals begin with an inspection of those radicals. We are looking to see whether they match that we might combine terms. In this case, obviously none of them do. However, we also note they are not in the simplest form. By simplest form, we mean that there are no common terms that can be removed from under the radical sign. We examine them by considering each individual term and whether they could be rewritten as the product of perfect squares. In this case, we notice that 12 is really 4 times 3. So we can consider using the product rule that the square root of 4 is really 2 and the square root of 3 would remain written as a radical. In like fashion, we notice that 27 is 9 times 3, and so we would have for this term 2 times the square root of 9, which is 3, and then the radical 3. Now in a case like 128, that may not be as familiar to us, we might want to go to our technique where we begin with a division stack using the smallest possible prime, that being 2 in the case it's even, and arriving at 64. As we build that factor stack, we know that we are done. Our task is finished when the final result is itself a prime. This allows us to consider factors when they are in pairs, so we know that 2 times 2 is 4, another 2 times 2 will result in a 4, and this 2 times 2 will result in a 4, leaving one remainder factor of 2. This concrete representation helps us realize that the square root of 4 can be removed as a 2 from under the radical sign. In like fashion, this 4 would result in a 2, as would this one, leaving 1, 2 still under the radical bar. Our next step then is to actually do the multiplication. 5 times 2 being 10, radical 3, added to 2 times 3 is 6, radical 3, minus 2 times 2 is 4 times 2 is 8, radical 2. Our final step would be to notice that we can combine terms, adding when the radical sign is the same, using that property of distribution in the reverse. The common term, radical 3, could be written, and then we would combine the 10 plus 6. Now all of this is done usually in mental math, so our final representation, 16 root 3, subtract 8 root 2, is actually our final answer. Noting that a radical 3 is irrational, and as is a radical 2, we cannot combine these two terms, so our final answer has two parts. It is 16 radical 3 minus 8 radical 2. That is our exact final answer.